All right, in this Delta Math, we're going to take a look at transformations. Now, when we're talking about transformations, we're talking about all four of the different types, one of which you haven't seen Delta Math on, which is dilation. Now, you talked about scale factor in last week's, and you saw what happens to points when they get dilated, but we haven't actually seen what the shape does. So if you take a look at these two, the red one is what we start with, the blue one's what we end up with. That's why it has the apostrophes after the letters. And obviously, the blue one is bigger, so it got dilated by some factor. So if you take a look between A and B on the original, it's 2 units. And then if you look on the blue shape between A primed and B primed, that's what the apostrophe is called, that's 4 units. All right, 2 times what gets me to 4? Well, that must be 2. So the second shape is 2 times bigger than the first. So what we're trying to do is we're trying to figure out what moves they made. So they would have had to make a dilation, right? So it would get bigger. And we're figuring it's got to be twice as big. And then it's not a reflection, right? Because it would have to reflect over just either the x-axis or y-axis or a particular line, and it won't work that way. It's not a translation because it didn't just get moved, so it must be a rotation. All right, now if you think about rotation, remember there's 90 degrees, 180, and 270. If you look at this one, it must be 180 because it's on the direct opposite side. All right, so take a look. It shows you a video of what happened here. And there you have it. Let's try another one on here and make sure we're catching what's going on. All right, so as we look at this, from the red to the blue, it's getting smaller. So you gotta be careful about which one is your start shape. So first thing I would say is we make a dilation, right? It's gotta be getting smaller. So pick between any 2 points that you want. Typically between 2 points that are on a straight line are easier to determine how long that is. So let's look at C and B and then C to B primed. So C to B is 2, C prime to B primed is 1. So we're going down, we're dividing by 2. So this must be a scale factor of 1/2. So if you forgot, multiplying by 1/2 and dividing by 2 give you the same number. If you don't believe me, take 6 times 1/2 in your calculator and 6 divided by 2. So 6 times 1/2 and then 6 divided by 2. All right, after that, notice that the shape isn't rotating. It's not being reflected. It just gets moved. So there must be a translation. All right, so you got to think about how much smaller this would be. Remember that we're going toward the origin as we go, so that we can figure out how much we're going over. So this one should be going down 6 units. All right, notice in the video of the replay there, the dilation actually changes the shape and it gets closer to the origin. So take a look at that shape as they go there. So when we multiply it by that scale factor of 1/2, it's actually going to get closer to the origin. It's going to be half of the distances that they are. So if you look at A, for example, you have x equals -6 and y equals 2. So you're going to cut both of those in half, and that's how the new A ended up at -3,1. And then they took that down and counted down 6 to get to the new shape. All right, if you have any questions, make sure to email.